Hello, my name is Ali Purnagdali. In this talk, I will present the results of an ongoing project that I'm conducting under supervision of my advisors, Bennett Schwartz and Fabian Soto. Tip of the tongue state, or TOT, is a metacognitive experience of imminent accessibility of an item when the memory system fails to recall that item. A feeling of knowing judgment, or FOK, is a metacognitive judgment about the likelihood of correct retrieval of an item in the future, regardless of the state of recall at the moment. In this talk, I focus on TOTs and FOKs when participants cannot recall an item. Research showed that having a TOT or a high feeling of knowing is strongly correlated with the possibility of correct retrieval of unrecalled information. These are examples of metacognitive sensitivity, which refers to the ability of a metacognitive judgment to accurately evaluate performance in different cognitive and perceptual domains. Although metacognitive sensitivity of TOT and FOK have been reported frequently, these evidences mostly come from measures that conflate metacognitive sensitivity with metacognitive bias, which is the tendency of participants to report a specific level of a metacognitive judgment. In this study, we aim to provide a bias-free assessment of the metacognitive sensitivity of TOT and FOK. To this end, we asked participants to answer general knowledge questions. One-third of the questions were non-factual with no correct answer. For example, what is the capital of Nigeria? These were used as catch-tails in our study. If recall failed, participants had to provide metacognitive judgment of TOT and FOK and to perform a memory recognition task. In this task, we presented participants with a response that was either correct or incorrect, and they had to indicate if they thought the provided answer is correct or incorrect. Finally, participants had to indicate their confidence about their performance in the recognition task. To evaluate the metacognitive sensitivity of TOT and FOK, we use general recognition theory, or GRT for short. For this, we feed a GRT model to the data to assess the metacognitive sensitivity of TOT and another GRT model to the data to assess metacognitive sensitivity of FOK. The two GRT models are quite similar with only one difference that I will explain later in this talk. This is a schematic representation of a GRT model fed to the data. The x-axis represents memory recognition and the y-axis represents metacognition. In the GRT model that evaluates metacognitive sensitivity of TOT, the y-axis is TOT, and in the GRT model that evaluates metacognitive sensitivity of FOK, the y-axis is FOK. There are a total of 3 conditions in this study: catch-tails, correct recognition, and incorrect recognition conditions. Each condition is represented by a bidimensional normal distribution in the 2-dimensional space. The catch-tails are represented by a no stimulus distribution in blue, and we centered it at 0 in both dimensions. The 2 recognition conditions are represented by distributions higher in metacognition and away from 0 in opposite directions along the x-axis. After fitting the GRT model to data, we estimated 2 parameters for all values of metacognition along the y-axis: the relative likelihood of no metacognition and sensitivity in the memory recognition task conditional to the value of metacognition in the y-axis. Next, we used the estimated parameters to construct 2 sensitivity versus metacognition curves, or SVM curves for short. An SVM curve to evaluate the metacognitive sensitivity of TOT and an SVM curve to evaluate the metacognitive sensitivity of FOK. This graph represents the results of the SVM curve evaluating metacognitive sensitivity of TOT. The y-axis in this SVM curve represents sensitivity in the memory recognition task. The x-axis represents the relative likelihood of no metacognition related to TOT. The black dotted horizontal line is the chance level in the memory recognition task. The red line is the SVM curve extracted from the model, and the lighter red bands are 95% confidence interval. The dotted blue vertical line is the objective criterion based on the optimal observer, which divides the x-axis into 2 areas: the area of high and low likelihood of metacognition. Based on this, we define metacognitive sensitivity as a higher than chance recognition sensitivity in the area of high likelihood of metacognition. Higher than chance recognition sensitivity in the area of low likelihood of metacognition represents memory processes in the absence of metacognition. According to this graph, the recognition sensitivity was at its highest in the area of high likelihood of metacognition, or when participants were experiencing TOTs. However, the recognition sensitivity was lower in the area of low likelihood of metacognition, but still above chance level when participants were not experiencing a TOT. The right graph represents the results of the SVM curve evaluating metacognitive sensitivity of FOK. The x-axis in this graph represents relative likelihood of no metacognition related to FOK. Similar to the TOT results, the recognition sensitivity was at its highest in the area of high likelihood of metacognition, or when participants were having a high FOK. The recognition sensitivity was lower in the area of low likelihood of metacognition, but still above chance level when participants were having a low FOK. In conclusion, these results indicate that TOT and FOK are associated with higher performance in memory recognition. These results are the first bias-free indications of metacognitive sensitivity of TOT and FOK. Thank you for your attention.